Question 11, you've been assessed on how to expand binomial expressions involving imaginary terms. Question 11 reads, which expression is equivalent to quantity 2x minus I square minus quantity 2x minus y times quantity 2x plus 3I, where I is the imaginary unit and x is a real number. Alright, before we get started, let's do a real quick review on our powers of I. Alright, so do you remember your powers of I? So the powers of I that we are going to be going over right now just basically shows you how to simplify powers of I, okay? So this is a guideline. If you have I, it's simply going to be I. But if you have a power of I that is greater than 1, it must be simplified, okay? So I square is equal to negative 1 because I is the square root of negative 1. So I square, the square gets rid of that square root. And then I to the third is the product of I and I square, which is the same thing as the product of I and negative 1, which is negative I. And then I to the fourth power, you can either view it as I square, which is negative 1 square, which is 1, or I times I to the third, which is I times negative I, which is negative times negative 1. Negative of negative 1, which is just positive 1. Alright? So you just need to know the first four. Now, why do you need to know the first four? Well, this pattern repeats itself. If you want to find I to the fifth power, I to the fifth power is exactly the same thing as I because it's I times I to the fourth. And it is I to the sixth for the same reason, I to the seventh, I to the eighth, and then the pattern continues. Okay? Alright, so with that in mind, let's go ahead and attack the problem. So we have the quantity 2x minus I square minus 2x minus I times 2x plus 3I. Now, since there are two ways we can do this, okay? So what we can do, we can expand this completely, which will involve a lot of work, and then simplify. But there is another way that we can attack this problem that's much quicker, which is realizing the fact that the left side and the right side of this minus has common factors, okay, which is 2x minus I. So let me show that to you. So you have 2x minus I squared is basically 2x minus I and 2x minus I minus 2x minus I times 2x plus 3I. So you notice that 2x minus I, that quantity, is identical to both sides. Okay, so we can basically factor out 2x minus I. Hopefully that will simplify our expansion process. So we factor out 2x minus I is as though we're dividing by that quantity. Alrighty, so when you divide or factor out 2x minus I, this quantity and this quantity are gone. They become 1. Okay, because when you divide these two quantities, these two products by 2x minus I, this is what you have left. So you're going to have left, you bring this down, 2x minus I minus, now you have to be really careful here. You notice that there's a minus. This minus should be distributed to these two terms here. Alright, to avoid making a mistake, let me show you an intermediate step. Whenever you have a minus in front of a quantity, you want to proceed with caution. Alrighty, so now we have 2x minus I times, and now this is what I was talking about. Just bring down the 2x minus I, distribute this I to these two terms, so we have negative 2x, and this other term also becomes negative 3I. Alright, so watch out for that. Now let's simplify the quantity in the second parenthesis. They're like terms that can be combined. 2x, positive 2x and minus 2x are opposites. They add up to 0. And then we can bring down 2x minus I. Now, negative I and negative 3I are like terms. So negative I minus 3I, imagine that there is a 1 here, okay, like there's an imaginary 1. So minus 1 minus 3, that's basically what you're doing. If you combine those two terms, you're going to have negative 4I. Now to finish this off, we're just simply going to distribute negative 4i to these two terms here. So when we multiply that out, we're going to have, let's see, 2 times 4 is 8. 8xi, actually it's minus, negative 8xi, and then this minus times the minus in the center becomes plus, plus 4i squared. So what did we talk about earlier concerning powers of I? We stated that if the power of I is bigger than 1, it should be reduced. Okay? So negative 8xi is good. We leave that alone because the power of the I is 1. But we have a problem here, ladies and gentlemen. This I has a power that's greater than 1, namely 2. So we're going to use our powers of I formula here to simplify that. I squared is negative 1, so we are going to replace I squared with negative 1. And then our final answer, if you write it in the standard form for complex numbers, it's going to be negative 4 minus 8xi. Okay, negative 4 minus 8xi. And the answer to question number 11 is option number 1. So this is how you can expand binomial expressions involving imaginary terms.